CK. Tonight we're going to build another Eurorack module. This is not going to turn into an all Eurorack all the time channel, but I still need some things in my shop Eurorack unit to have the foundational pieces. And one of the things that you may have noticed is I use a kludge of wires to get to my amp. So I bought a Befaco output module, and we'll put that together tonight so I can get rid of all the jumper cables and just use a straight amp cable after I put this all together. Hope you enjoy it. So here we go. Befaco output do-it-yourself kit packed by Befaco in Barcelona, Spain. Support at befaco.com as the email address. I have not had to write to them yet, so I don't know how quick they are to respond, but I'm going to assume they're as good as some other folks. What's in the bag? One other thing I want to highlight, I complain a lot, well, you know that. I complain a lot about not having good parts trays. Most of the metal parts trays I can find are magnetized, and I really dislike magnetized parts trays. So, but I did find these on Amazon. They're a little flimsy, but they're stainless steel, and they're, as you can see, they're rectangular instead of round. I'll put a link in the description. So let's see what's in the bag. First, paperwork and the circuit boards, 2 of them, and the front panel. More stickers. I've already put these stickers up, so I don't know what I'm going to do with those. Eurorack cable. Some knobs and knurlies, various resistors and capacitors and transistors and LEDs, bag A. This company separates the parts for each circuit board into bag A and B, and that works. I like that style. And another panel nut wrench. So let's see what the piece of paper says with it. It's the output kit. And I'm on the wrong side. Thanks for choosing it. Okay. Nothing. Standard steps. Standard steps. I'm not seeing anything in here that is out of the ordinary. Yep, so we'll dive in and put this together. So we'll put bag B away for a while because that's the panel stuff and that's panel stuff. And that'll be panel stuff. Let me open the circuit board bag. Circuit board and panel. I kind of stuffed them both into the same bag, which doesn't matter one way or the other, of course, but just interesting. So that'll be, again, it's got regular TRS, or probably in this case TS, outputs, and typical 3.5 inputs, Eurorack style inputs, and then a Q in, and I'm not quite sure what that's for. We'll look at that. There's a button that goes right here, I believe, and headphone output, that's the volume control. Geez, so we'll get to that further on down the road. And there's the output board. It's got 4 surface mount, 4 8-pin surface mount components already in it. Let's see, Oops. They're Texas Instrument TL072C. So these are op amps. It's the only thing interesting on that board. On the second board, nothing, but again, this is another Befaco that has two interesting characteristics. First characteristic is the solder points are very close together, closer than on many other motherboards or circuit boards, so you have to be a little bit more careful when you're soldering these things up. The other thing, and again, I pointed this out on the MIDI thing, these circuit traces are not straight. They meander. They've got little wiggles in them. I'm not sure why. Again, I'd love to know what piece of software they use that does that. Now we'll go fast, of course, through all the resistors, and there's quite a few, so we'll be speeding through that. Oh, and before I start, I do want to point out, this is true on this one, the silk screening runs off the side of the board, and it's often hard to read even where it doesn't run off. Again, this board is packed tightly. The pitch on the components is a little shorter than on other boards, so if you can't see the component name or number on the silk screen, just remember the back of the manual has a good drawing, and the online instructions have a good drawing where you can find it. Now this next set, he does have an interesting comment. These are the quarter watt 75 ohm resistors, purple, green, black, gold. Are 15, 16, 17, 18, place all, then solder all. I don't know why he specifically calls it out as the way to do that. I'm looking to see if there's anything particularly interesting about the layout. I mean, 15, 16, 17, and 18 are not, they're not too unusual. Maybe it's because, and I think you can see this, they're in series. The two resistors on each side are in series, and the two solder points for the mating ends, or the ends of the resistors that make the series, are joined, so perhaps they've run into cases where people have put one resistor in, done some soldering, and filled in both lead holes. So maybe they're just saying, hey, put these all in at one time so you don't accidentally fill up a solder hole. A nice thing to pass along from experience, I'd assume. Next step, all the resistors are now on. The next step is the ferrite cores, and I forgot to mention this. As you're going through putting the resistors on and clipping the leads off, find a couple of likely long straight leads, because you're going to need them to put them through the ferrite cores, which is a little cylinder of ferrite pressed ferrite material with a hole in the middle, and you get your resistor lead. Oops. Get your resistor lead, if you can pick it up. Get your resistor lead, put it through the ferrite core, and bend the leads. And then it goes in the circuit board, just like a resistor or capacitor. The designer of this kit did the same thing on the MIDI thing I built the other day. He's conditioning the power, putting a little inductance in the power lead or power trace, and we'll solder these on with no delay, because they can rattle around a little bit and you don't want them to come loose. And have to try and find a ferrite core rolling around on your shop floor. These went on just fine. And next we've got 6 diodes to put on the board. 4148 Zeters and 58 17s. And same as the resistors, these diodes are in series, so you want to solder them all at the same time so you don't clog up the hole for the next diode. These are a little bit of circuit protection on the output side. And now the IC socket. We only have one on this board. Making sure the notch is in the right place. Getting some locking tweezers to hold it in while we solder. We'll put this IC in and let's see what it is first. It's another Texas Instrument part. It's a TL 072 CP. Yep, another op amp. Again, since this is, in effect, this is an amplifier. Dot in the right orientation, and IC is in. Then a bunch of capacitors. I'm going to pass on that for this session because the cats need to be fed. We've got 5 electrolytic caps, all the same value. Again, this is a pretty straightforward build. It's basically, I mean, of course, it's basically just an amplifier, and they're pretty straightforward. He's just done some interesting things with the op amps and the mixing, so that'll be fun to play with once we get it up and running. And obviously, the designer of this board and circuit, or board or circuit, cares a lot about the quality of the power that he uses. I appreciate that. He wants you to hear the sound coming in. He doesn't want you to hear anything from the power supply or circuitry itself, which is really nice. I appreciate his or her layout and design work. Because basically there are extra capacitors in this circuit and build that other people might not have it included. Oops, that one got a little snaggly on me. Again, as I've said, the pitch on these traces on the board are very, very close together, so sometimes the components don't want to quite play. See, like right there, there's so little space between the capacitor leads. It would be easy to bridge them, so when you build this, just be aware the way the solder points are so close together. You want to keep an eye out for bridges. The other thing, and I mentioned this in the MIDI thing video, because they use good quality circuit boards with plating that goes all the way through the board, you also get wicking of the solder all the way through the board, which ensures a great connection, but it can also, if you think you've shorted something, you may have shorted it not on the side you're soldering on, but on the other side where the solder may have wicked through. Okay, that's all the electronic components except for the LEDs, and we'll put those on when we mate the stack and put the control panel on the front. Now we've just got some mechanical connections to do. So I'm going to open up bag B, which has got some mechanical bits. And I'm going to move these over here for right now. And use this tray for mechanical bits. See what's in bag B here. And we've got small jacks, big jacks, oops, panel nuts, which I almost lost on the floor, which would have been sad. Our volume pot, or it might be a mix pot. We'll see once we get it all together. Switch. Standard Eurorack power connector. The riser to hold everything together. And now we'll do the main power connector. Double checking our orientation. I always triple check this to make sure, as everything is mated up, the stripe and 12-volt negative is in the right place. Double and triple check that, or you will be sad. Here's the power connector. Then we're going to get to putting the front panel on. And I'm still trying to figure out where all this goes. So, I think it'll go like this. And this is where, again, a good picture helps. In this day and age, I think it's incumbent on builders to put digital photos of many of the steps, and you can't have too many digital photos. It just is reassuring to the person who's putting things together. It makes your job as a creator easier because you get less support calls saying which way does this actually go, I put it together wrong, whatever. So I think it's really valuable that you load up your kit and your instructions with photos. Fortunately, the photo on their product description page shows the orientation. So we'll be stacking it. Yep. We'll be stacking it like so. So I'm going to pause for a little bit and then we'll do that. So we're going to do components on the control board first. So we're going to put the switch and the jacks. The jacks are easy because they slide in and there's enough spring tension on the leads that they're not going anywhere. The switch is not got any spring tension on the leads, but again, you don't want to solder it. I am doing it right. It's the problem, the challenge is that there's silk screening on both sides, of course, because we mounted a bunch of components on this side with silk screening, and then it says make sure you put it on the silk screen side, but this is also silk screened. So I think marking the board A and B or front and back might have been worthwhile. So we've got the mini jacks kind of hanging in place. Then we'll drop the LEDs through. The last time when I built the MIDI thing of theirs, I was a little concerned about these LEDs because, as you can see, they're tapered at the tip, so it's not as if the whole body of the LED goes through the front panel. They have just the tip of the LED goes through, and I thought that might be a bit of a problem. It turns out not to be a problem at all. However, I think I should have put the LEDs. I think I would recommend the LEDs go on before these other components go on. And just because I think that that's the right thing. You don't have much room to guide or even see where the LED hole is. And he doesn't, well, I guess he does. This is probably, when you're building this, the LEDs are the worst possible thing for not soldering beforehand, because you're going to have to play with them. Now these leads are a little bent, So I'm going to flatten them out with something or other, so that when we do get to the point where we're pushing them up the board, they're not going to go the wrong direction and frustrate us. Put all those in. Come on. Now I'll go back and put the jacks and switches back in. Again, I think I would change the order of assembly and put the LEDs in before you put these other panel parts in. It's true that they are going to protrude above them when it's all assembled, but we're not all assembled yet. Okay, there's all that wonderfulness. Now the pots. So both pots are the same. We're going to be dropping them in here. Now, see, that's... See, he doesn't have a hole, unless it goes this way. I'm sorry, this is a little bit Jim Crackery here. I hope that's right. Because he doesn't have a separate hole for the mounting pin on this jack. So you've got to double up with the mounting pin on the jack above it, and that in and of itself, oops, and I just splayed the leg out. That in and of itself is not necessarily obvious. There we go. Now, as you can see, we're going to put the pots in here, and when we put the panel on, where's the panel? I'm doing this so you can get an idea of what we're talking about here. When we put the panel on, the pot will sit up. There'll be a gap between the PCB and the bottom of the pot. And that's really important because, as you can see, underneath the pot are all the solder points for the components on this side of the board. And so what I'm going to be doing here right now, real quick, is I'm going to go through and look at these solder points again with my flush cutters and see if there's anything sticking up just a little bit too much that might contact the bottom of the pots. I don't think there is. I'm just kind of giving it one last little haircut to make sure. Okay, now we can put the front panel on it and get all our positioning right. Oops. Get our positioning right, not get our positioning wrong. And of course we do a little wiggling to get everything to seat correctly. We're gonna take the switch, screw, and lock washer, nut and lock washer, almost forgot the lock washer. I'm not going to use the lock washer. It looks ugly as heck, and I'm going to rely on, again, I'm not ever going to take this on the road, it's going to be in my studio. So basically the spacing and orientation is going to be driven completely by the jacks, because the pots have some slop in them. They can move up and down. The switch has a little slop in it, but the jacks are what is controlling the distance between the control panel and the control board. So that is our focus to get one of the jacks soldered down and then screwed down with a panel screw to make sure everything's fine. And to do this, to help me do this, I'm going to use my locking plier tweezers to squeeze the board together at the right point, and I'm not at the right point right now, to squeeze the board together like that. So I've got plenty of tension to tack that first socket in place. And guarantee myself the right distance. So I only tagged one leg so far, and I'm going to double check this, and I'm going to pull the tweezers off because it is pulling a little bit to the side by doing that. So I'm going to look at the other side, get that oriented too. That looks good. So I can put the panel screw on the socket that I had tacked down first. Let me get my fancy Befaco. I'm using the wrong size. My fancy Befaco panel nut wrench. Okay, so that one's in place and looks flush. I'm going to do a similar thing on the other side, just to make sure this is all oriented perfectly. Pull the pots up a little bit. A little. Again, this is where you just take your time, be patient. Okay, that's good. That gives me the orientation I want. I want to come down a little, tiny bit more there. That looks good. Now I'm going to pull the pots up flush against the front. And as the pots pull flush up against the front, they're going to raise themselves above the PCB, so there's not going to be a problem with interfering with the back of the pot bridging any of this already existing solder points. So this is why, again, as you look at this, whenever you're putting a front panel on a Eurorack kit together, you've got to do a little bit of analysis and say, what's the key component that drives security and drives distance? And in this case, again, it's these 3 sockets. So that's what you get in place first, then you make everything else do its thing. But now we can drop the LEDs, push them up, push them up, push them up, and the switch is in a good place. Let me tighten that a little bit more to get it in its final position. Okay, now we can solder it all. And as we solder it, one thing I want to point out again when you're doing these on the sockets, and it's going to be even more important on this board with the bigger TRS style socket, don't skimp on the solder. These are the stress points. There are going to be patch cords going in and out of that all its life. So don't hesitate to put enough solder on the leads to make sure it stays in place. Double checking to make sure nothing got bridged. Now this is a little, the challenges here are these pot pins, because they're so close to the other components that you have to be careful not to cook them. This capacitor in particular is really close to that pin, and I don't think I touched it, so I think we're good. It's metal can anyway, so you'd have to dwell on it for a little while. This poor little resistor is also close to a lot of other pins. But the control board's ready, and I'm gonna, now that I've got everything soldered in place, I'm gonna do a final tightening on the panel nuts. And that looks good. So now just a couple more things to do. Now we're going to put the big old TRS jacks in. Make sure we get the pin orientation right. Again, we don't solder these yet. Now we're going to build the stack. And make sure, as you're building it, it'd be hard to get it wrong, but that doesn't mean it's impossible. But you want to make sure you get all the pins in the male header correctly into the female header, nothing bent, nothing misaligned, or else obviously it won't work. So we'll push those together firmly. And this transistor is in the way. There we go. So that was interesting. This transistor needed to be bent out a little bit to not interfere with the pin header. But everything is in place correctly, it looks like. Now let me solder this up, and even more importantly than the patch jacks, the 3.5mm jacks, these 1/4" jacks do not skimp on the solder, because they take a lot of force as you're putting headphones in and out of them, amp inputs, or amp jacks in and out of them. I let the camera go off. I apologize for that. So all we did was put the knobs on and do the final tightening of the jacks and put the ribbon cable on. So as you look at this, you'll notice that because of these 1/4" jacks, this is a slightly deeper module than many Eurorack modules, so make sure your rack has the depth to be able to take this. I'm not sure. So build that in to your decision when you're buying this. Is it going to be too deep for the rack you want to use it in? So it's all together. It was a good build. Pretty basic, because again it's just an amplifier effectively. So the circuitry is not too complex, but the trickiness of the multi-level board is interesting. But all in all, another good kit from Befaco. Now I'm going to mount it in our test rack, and we'll see how she sounds. So we're plugged into the shop amp, the custom amp I built a couple of months ago. You can see that video if you want. And then we're plugged into the Eurorack test jig I built last week. And as you can see, we're going to be going from the Duskwork VCO into the output, and the output's plugged into the amp. That I also have Befaco's MIDI thing in there, but we're not going to be using that tonight. We're just doing straight pumping audio out. And you'll notice on the base of the test jig, we've got a frequency central Routemaster power supply, which you can also see a build video of that. I like it very much. So first thing we do is turn all our volumes down. So we've got power on the VCO. I don't see any LEDs on the out, but let's turn up the VCO. So I know that's cranking. Okay, as I turned up the VCO for the triangle wave, you may have seen we're plugged into the left mono jack. As I turned up the VCO, the LEDs came up. So you can always see if you've got a real input there, because it'll sense the voltage going in and crank the LEDs up with that. Now I'm going to turn up the master gain. And that sounds good. Let me take the saw wave up. Do a little mix. So that's it. Works fine. It's a good output amplifier to a good performance amp. So this is a nice little unit. Again, Befaco, this is my second unit of theirs I've built. They seem to make some really solid stuff, and I like their designs. I hope you enjoyed it.